Hello and welcome to a episode of Rockin' Science Podcasts. I'm going to run you through a series of instructional informationals on science and specific topics that we're covering this year in my class. I'm Mr. Spratt. Today we're going to talk about the introduction to science, and it begins with the first step of the scientific method, which is an observation. Observations are based on our human sensory perceptions. We see it, we hear it, we feel it. These observations are things that we, inside of our heads, internally, we do this mental process where we assign meaning or explanation or some kind of conclusion based on that to create an explanation. When we do that correctly, we have made an inference. If we do that incorrectly, we have developed a misconception. Misconceptions are dangerous because they tend to stay with us. They things that we think to be true, but are really just false inferences that have not been corrected. So let's go back to our inferences based on these observations. Now, our inferences can be more precise when our observations are bound in reality. For example, if our observations are tied to a measurement, they have a numerical value, some kind of quantifiable amount that they can be related to. How long is something? How far is it from one point to another? Whether we're talking about in space, like a distance, or how long in time, a duration. So when we make a measurement, we're using one of these three types of dimensional qualities, such as the length, the distance from one point to another, the mass, how much matter is in a substance, and time, which we really are just perceiving as an event after an event or the duration of things. Now, to accompany scientists in their observations and to make good observations, they use tools. A lot of times those tools enable us to extend our own natural perceptions to a higher level. For example, a pair of binoculars allowing us to see something farther away than our eyes could normally perceive, or to see something very, very small, using a microscope or an electron microscope to really see something that is just beyond, well beyond the range of our vision. Those tools can also help us see things or hear things or sense things or make observations about things that we cannot, that are well beyond the limitations of our physical bodies. For example, our eyes are unable to perceive in the ultraviolet wavelengths as well as the infrared wavelengths. And by having tools and detectors, we are able to look at data or look at observations in ranges of energy that we cannot see with our human eyes or sense with our human perceptions. If you have a bunch of data points that are around a similar item, or you start grouping similar data together, you begin to develop this classification system. Now, classification systems are incredibly useful in science because they also help us make proper inferences. For example, we will classify the planets as terrestrial or Jovian. Terrestrial planets being the ones that are more Earth-like, of rocks and metals, and then the Jovian planets are more Jupiter-like, of lighter gaseous compounds. Those classifications help us study things specifically and analyze and make inferences about their similarities as well as their differences. Using those three dimensional points as length and time and mass, we can combine some of those measurements to get more measurements or other data points that we can look at and use for our inferences. For example, density is a measurement based on the amount of matter within a unit of space. And that unit of space is a addition of the length factor of dimension, right? So how long something is. If it's 3 dimensions, it's got a length, and it's got a width, and then it's got some kind of depth or height. And those three dimensions combine to make a whole a whole that combine to make a whole. So that's what the volume is. It's how much space something is occupying. How much, like, so the volume of a room is how wide the room is, how tall the room is, and how long the room is. We will talk more about the specific units that these things are measured in. And you might already start to be thinking, oh, it's like square feet of a room. Well, it's actually going to be in cubic feet of a room, because square feet is the length by the width, whereas cubic feet would be the length of the room by the width of the room by the height of the room. That's why flooring is put down in square feet, of covering a flat surface, whereas you would use volume to fill a pool. These measurements aren't perfect when we do them in a lab, so we will also need to apply what's known as percent error, or percent deviation. And these are measurements, basically quantified formulas to tell us how close or how far off of the accepted measurement for something we really are. And that lets us know whether we're designing our experiments or our science in the proper and most responsible way. We will calculate percent deviation on some of our experiments. We will be looking at the units that are common in various scientific subjects, whether we're talking about millibars of mercury and atmospheric pressure, or we're talking about square miles, or even kilometers that we'll see. The metric system and the English system crashing into each other here in the American education system. But we will do fine, because we will be able to use these units. We will convert between them. We will be able to analyze graphs and data and tables, and that will tell us all we need to know about our Regents test. Because at the end of the day, my students want to pass their Regents test and have a good grasp of the content. So with that, I'm going to run us through really fast. If you feel like you got all that you needed from this podcast, it's over. But I'm going to go ahead and say it all one more time. If you're going to take notes, this is the part that you would rewind over and over again. Observations are sensory, something that we see, touch, hear, smell, feel. Those observations are enhanced by tools that allow us to either extend our natural perceptions or extend them beyond our natural perceptions to see data points. Those data points are observations that we have quantified. We have quantified them by giving them some kind of measurement. We've assigned them a length or a time or some other quantifiable constraint that gives them some sort of meaning. If we put all of those quantified observations together by groups, we would be classifying them. We will classify these different observations, and once we have done that, we will be able to make scientific inferences, some sort of conclusion or revelation about, or prediction about, what we see and what we think that means for our overall understanding of that topic and those data points. Those measurements are taken by humans, and they are innately going to be flawed, so we will use percent deviation or percent error formulas to calculate how far off of accepted scientific values we are. Thank you guys very much for joining me on this episode of Rockin' Science Podcast. I was Mr. Spratt, and that was a lot of fun. I hope I can make some more of these for you.